अच्छा, we're starting. In tetrahedral coordination DT, 4 coordination number and 4 ligands are there, and there is central metal atom. Central metal atom remains at the center, and the ligands are at the alternative corners. So we can see 2 bonds are above the plane and 2 bonds are below the plane. Here the ligands electrons and d electrons of metals feels much lesser repulsion than octahedral entity, as there is only 4 ligands. In octahedral geometry there was 6 ligands. Again, the ligands approaches in between axis, that means it does not approaches on the axis. In the picture we have already discussed about it, and there is 3 axes x, y and z perpendicular to each other, and we can observe that 2 types of d orbital we already have mentioned in the earlier. There are 5 d orbitals of same energy, that is degenerate, and this degeneracy is breakdown in presence of some asymmetrical ligand field, and dx square minus y square and dz square oriented towards the center of different planes, which feels much lesser repulsion, whereas dxy, dyz and dzx, the orbitals, the lobes of the orbitals are oriented towards the middle of different edges. We already have discussed about it, and so these 3 orbitals feels much more repulsion than other 2. So dxy, dyz and dzx feels more repulsion than dx square minus y square and dz square. Here all the ligands are not along the axis, so the degeneracy is already breaks down. So here we can draw the energy diagram of and the degeneracy of d orbitals. In absence of ligands, the 5 d orbitals are of same energy, remain in the stable set, but in presence of spherical symmetrical field, the energy of the degeneracy remains the same, but energy of the d orbitals get increased. So this is the barycenter. With respect to it, when the ligands approaches, the T2 orbitals, that is T2 set dxy, dyz and dzx, have much more higher energy than barycenter, that is remains above barycenter is 0.4 del t, and the E set, that is contains dx square minus dz square, remains at the bottom, which is below 0.6 del t value than barycenter. So it is stable and it is not stable due to higher energy. Okay, so in this case the del t value is much more lesser than del O value. That means crystal field stabilization energy or crystal field splitting energy in tetrahedral entity is much more lesser value than CFEC value of octahedral entity, which is about near about del t equal to near about 4/9 del O.